Okay, so in this video, I'm going to solve those 4 equations and inequalities that are on the special cases pages, the last 2 in that solving algebraic equations and inequalities foldable. It's behind your table of contents in your interactive notebook. So when I see this problem, the first thing that I need to do, the goal is to get all of my x's on one side. So to do that, I have to start by distributing. So, I'll do it above. So we're going to distribute this -3 to 2x, so that gives me -6x, and this -3 to 4, so -3 times 4 is a -12. And I'm going to do the same thing on this side. I'm going to distribute this 6, because this is implying multiplication, so that's -6x. And then -6 times 2 is -12. So at this point, you might say, well, this is the same equation. And so that indicates to us that no matter what we put in for x, this is going to make a true statement. But if you want to keep working, if you don't see it, I'm going to add 6 in order to get my variables on one side, but then I'm left with -12 equals -12, which is a true statement. So that means that the answer is all real numbers. So this symbol here is all real numbers. So that's one of our special cases for an equation. Let's see another example. So same thing on this one is I'm going to distribute. So I'm going to pause this here. I want you to try and distribute on your own before looking at what the next step. So you can check your distribution. So on my left-hand side, I distributed the 2 to the -3 and the -x. And then on the right-hand side, I distributed -2 to x and to this -3. So now I have -6 minus 2x equals -2x plus 6. So at this point, I see that this 2x and this 2x are going to end up canceling each other out. And then I'd be left with -6 equals 6, and that's a false statement. If you don't see that, let's go ahead and bring our x's to one side. So I'm going to add 2x to both sides, and I see that -2x plus 2x on both sides is going to bring us to 0. So then I bring down what I have left, and I have -6 equals 6, and this is not a true statement. So this is a no solution. And the symbol for that is going to be a 0 with a line all the way through it. Now let's look at inequalities and their special case. So just like the other 2 problems, we approach inequalities the same way as we approach equations. So the goal is to get the variable on one side. The first thing we need to do is we need to distribute this 2 to our x and our 1. That gives us 2x plus 2 is greater than 2x minus 1. And so for those of you that were in class and remember this, we saw that right off the bat, again, this 2x is going to end up canceling each other out. But if you don't see that, we can go ahead and try and bring them to one side. So if I take this 2x from both sides, I get the statement bringing down, because 2x minus 2x is a 0. So then I have 2 is greater than -1, which is a true statement. So again, this is going to be an all real numbers. So since we ended with a true statement, we're good to go on that special case. For inequalities, they can also end up with all real numbers. Now our last example, same as the other ones, we're going to approach it the same way. Our goal is to get all our x's on one side. So first, I need to distribute this 3 to the 5 plus 2x. So I'm going to bring down the 10 plus 6x and then distribute the 3. And again, much like the other ones, we see, okay, well, these 6x's are going to, we don't want to say cancel each other out, but they're going to, when I subtract 6 to try and bring it to the side, we'll see, just like the other problems, that gives us actually 0 x's. So that's just 0. So we end up with 10 is greater than 15. And that is not a true statement. So that means we have no solution. So the shorthand is 0 with a line all the way through it.